Hello, Philip. Thank you very much for accepting our invitation for this interview, and I'm very glad to have you here. Today, we are going to talk about proficiency testing, what can go wrong, as we have already talked about this. We are going to go through the details how a proficiency testing is going to be organized and what are the major of possible errors which might happen during organizing and performing proficiency testing. For the beginning, may I kindly request you to briefly introduce yourself and provide us with some information about your experience and background, especially in the field of proficiency testing?
Thank you, Hamid Reza, and thank you for the invitation to join the discussion. And my name is Philip Briggs. I work for a business called Proficiency Testing Australia, which is I'm general manager of the group. The business started in 2006. Before that, it was part of NATA, which was the Australian accreditation body. We are a subsidiary, fully owned subsidiary of NATA. We have office in Sydney. I work from Sydney office with 7 other people, and we also have a branch or an office in the city of Brisbane, north of Sydney. My experience has been probably now 30 years with proficiency testing, both in coordinating programs, managing programs, doing consultancies, being a NATA assessor for proficiency testing, and doing training on proficiency testing. So I guess that is my introduction. Thank you.
Okay, thank you very much. My first question is could you please let us know what are the main factors which might affect the quality and outcome of a proficiency testing from the PT provider point of view?
Okay. The quality of if we talk about quality in proficiency testing, my understanding is we're looking at undertaking they call it different words, the program or the scheme or the project for the laboratories to best practice, to best international practice. And fortunately, as a proficiency testing provider, we have a ISO standard to use, which helps us undertake the program of proficiency testing with a set of guidelines which should ensure that there will not be problems with the program. The ISO standard is an ISO 17043, and it gives general requirements for proficiency testing. Now, there is a lot in the standard, but to keep it probably in summary, to simplify, the major factors is if with most proficiency testing, it's done with subsampling a bulk sample. You can conduct proficiency testing with a highly characterized reference material, but that's an expensive option. So most proficiency testing providers subsample for testing a bulk sample. So if that is the plan or the way that the proficiency testing is planned to be done to provide samples to the laboratory, for the quality, the most important step is to ensure that there's no significant variability between the samples. And the way the standard approaches that, the ISO standard says that the provider undertakes a step process called homogeneity testing. So a proportion of those samples that are produced are tested before they're sent to the laboratories. And the proficiency testing provider undertakes a statistical analysis of selected tests to ensure that there's no difference between the samples, because that would be the, if there's the most important step, that's the most important step, even before laboratories receive. So all of this work has happened before the samples even received by the participating laboratory. So I'd say Hamadress, probably I always believe that the most important step is the homogeneity testing, but we can talk later about the reports and etc. later. In terms of the statistics, you need for the quality of a PT, you need a statistic that is easy to be understood by the participants. And internationally, the most accepted way for testing programs is a Z-score, and there's easy parameters in the standard on how to interpret a Z-score. And if in the reports the participant has that data, they can actually calculate a Z-score themselves. So it's not like we run statistics and the participant does not understand the statistics. A good quality program has easy to use and easy to be understood statistics and the statistics are there with the primary aim to evaluate laboratories' testing performance. So I guess they're the two things. One's the statistical and the other's the planning step with the homogeneity.
One of in terms of statistics that you just mentioned, one of the major concerns for PT providers, and this has been always the concerning point for us too, is the number of participants registered for a certain PT round. And proficiency testing providers need to specify the minimum acceptable number suitable for having statistical analysis in order to give the correct signal to the participating labs about their performance.
Yes.
And what are the considerations for specifying this minimum number of participants in order to have a reliable evaluation of the participants, and how we should come up with this minimum number? And my question is that, can we say that still PTs with low number of participants are reliable and participants can rely on the signal of the performance given in PT reports with low number of participants?
Okay. Well, the definition of proficiency testing talks about an interlaboratory comparison in the standard, and the word interlaboratory comparisons define to say 2 or more laboratories. Now, that is interpreted that if we say 2 or more, maybe a large program has 20 laboratories, but let's say we have 2 laboratories, that is still a valid proficiency test, because the first laboratory could be termed the reference laboratory, the one producing the assigned value for the determination. The second laboratory couldn't be the participating laboratory. So, for example, today I produced a proficiency testing report for a customer. However, that laboratory was the only participant. We had to source a reference for that material, which we did. And then for the statistics, then the number of laboratories then determines the type of statistical approach you would use, because we would not be able to calculate a Z-score because we had no standard deviation, okay? But we can, with the standard, an accepted way to do that is to keep the most simple statistics in proficiency testing is you have the known result, which is your reference, and you have the lab result. So all the proficiency test is a comparison between those two data points. And if we can set a limit, the most simple way to do that is to calculate the difference between the two results. A more common way then statistically is just to calculate the percent difference. Now, in a lot of methods, there are precision estimates stated in the methodology, and it gives a percentage variation that would be expected by that method. So you can set that as your limit. So if there are small numbers of laboratories, or you can have your sample as well, there's a few ways you can do it. You can purchase a reference standard where it's highly characterized and you have that reference value and an uncertainty. So there's your value. So, but your statistics could just simply be percent difference between the lab result and the reference material result. If no reference material is available, okay, there's still some options. The laboratory, or you have confidence in another laboratory that can undertake the same testing and they could provide the reference. Now, that is statistically not ideal, but it's better to do that than nothing at all. But I think most laboratories' understanding of a proficiency test is an interlaboratory comparison with a number of laboratories. And that's PTA's most common approach. So statistically, PTA has set a minimum for Z-score analysis, and our procedures say we need a minimum of 6 laboratories, and then we can undertake a Z-score. If we have less than 6, we haven't got confidence in the assigned value, because by Z-score, we're calculating the average of the results. And if we do not have a large number of laboratories in the interlaboratory comparison, by chance, they all could be incorrect, and then we have the wrong reference. Okay, so statistically for an interlaboratory, 6 is our minimum. But of course, the more laboratories in the program, your confidence increases in the reference calculation by average, if we're doing it by average.
In order to conclude, you mean that if we have a reference value as the assigned value and the prescribed value for the standard deviation of the proficiency testing, the number of the participants is not a concern anymore. And even within 1 or 2 labs, you can perform, and even you can calculate a reliable Z-score. Am I right?
Yes, you're correct. If your sample is a reference material, you can calculate still a Z-score, but your assigned value is your reference value. So it's a highly characterized sample. So it's, as you say, you can have even 1 lab, that minimum is not a concern. But if you're doing the program not by a reference material, but by a bulk sample, subsampled, and then calculate average, you need a larger number of laboratories.
Okay. One of the main issues in organizing PTs is the transportation of the samples, especially for temperature-sensitive samples in food testing or microbiological testing of water or similar areas. And sometimes even when you organize your PT at an international level, it is not possible for you to ensure the integrity of the samples during transportation. How PT providers should deal with this issue? And is it possible to only quantify these possible changes in the sample and include it in your standard deviation or in the uncertainty of the assigned value, or use Z prime score instead of Z score in order to include the uncertainty of the assigned value, which might be affected from this transportation? Can you please provide us with your comments about this?
Well, I guess first part of the question is, how do we deal with transportation for time sensitive? The samples would need to be packaged with, there's a lot of different packaging available now on the market with freezer bricks and more advanced packaging to ensure that the sample remains at a temperature where it will remain stable. That's one way to overcome that. The other part of it is you can, with PT, organise a trip control sample where it is sent to the laboratory, then the laboratory returns that to the organiser, and then they get that tested. So you're checking on conditions of transport to see if it survived. The other way to do that is to put a temperature monitoring device with the sample, and you can then get real data of what the temperature was over a period of time. These are things that PTA has to deal with from Australia, because we have laboratories in other parts of the world. Some locations, yes, there are still transport difficulties to arrive in the set time, and then we cannot progress. that is why in the standard, when we talk about samples that by characteristic are unstable and need to be at a certain temperature, that's why the standard talks about doing stability testing at a period of time that would be probably equivalent to the transporting the sample. But that doesn't replicate exactly the possible temperature variations in transport. But, that's the first part of the question. Now, Hemadresa, would you mind just repeat the second part for the
For the second part, I meant that sometimes you include the possible effects of these transportation effects in the uncertainty of assigned value, and if it is considerably large, you can use Z prime score instead of Z score in order to include the possible changes which might happen during transportation.
That is true, and that's by the ISO standard is an approach that you can use. So the interpretation of that is very similar to the EN ratio that's used in the calibration programs. Mm-hmm. Sometimes this information needs to be input from the program technical advice to tell how much influence that may have on that measurement uncertainty for that material, and there might need to be some calculations made. However, sometimes there may not be an effect. You're expecting an effect, and you run through your standard statistics, and the laboratories are all performing well. So if that's the case, I wouldn't change, because the laboratories, even with that additional factor of effect of transportation, it has not affected the sample. Hence, it has not affected their ability to test or their performance evaluation. So I'd probably only change and look at other approaches if it seemed to disadvantage one of the participants. But if everyone performed well, I would just leave the statistics as they were. Mm-hmm. Mm-hmm. Okay.
Okay. My next question is that I know that PTA organizes PTs in many different areas, from chemical testing to mechanical testing for different types of samples. And as far as I know, many of the technical tasks are subcontracted, including sample preparation or homogeneity and stability testing.
Yes.
And what I would like to know is that I know the difficulties in this area, and management of these subcontractors is a difficult task. What are the key points that you consider for evaluation and management the quality of the subcontracted activities?
Okay, our primary criteria for selection of subcontractor, and we're usually in that case talking about the supplier of the sample that we intend to distribute as a proficiency test sample. If it comes from a laboratory, we, as a criteria, PTA ensures that the laboratory is an accredited laboratory, so that it's already had undertaken both its management and technical competence has been assessed and is deemed to be adequate. So then, as a PT provider, we do not then have to run that same assessment because it's already identified and proven. Our other supply is from an accredited proficiency testing provider that may produce the samples. PTA does subcontracts all our sample supply. So we depend on other proficiency testing providers that produce the sample. So that's our other selection. So either an accredited by 17025 for as a testing laboratory, or ISO 17043 as a proficiency testing provider. And that's our criteria. But we also monitor the subcontractor's performance to check, did they supply what we asked? And in terms of our first question we had on quality, was the sample suitable for the proficiency test? or were there problems? So if it was homogeneous and the laboratories produced good results, well, it's a indicator that these samples were suitable for the PT.
Okay, thank you very much for your comments. In organizing PTs for a specific PT scheme, when we organize it in different rounds, sometimes we use the consensus value of the participants as the assigned value and the standard deviation of the round. But in the next round, when we notice that the variation is too high or too low, we prefer to use a prescribed value for standard deviation, and for assigned value, maybe we use expert laboratories approach or use formulation or other ways to determine the assigned value. My question is that, do you think that there should be a global approach? I mean that you know that for all the rounds, you need to take these approaches for determination of assigned value or standard deviation, or it is acceptable to use a case-by-case basis in order to determine the most fit for purpose values for assigned value, and especially for standard deviation of the PT, because for unknown samples, typically consensus value is used for assigned value. But for a standard deviation, you might have different choices. Horvitz equation, round, or your historical data even can be a good estimator. What are your comments about this?
The approach that PTA uses, if we have a program with historical data and one of the rounds varies and the standard deviation might be quite large and it's not acceptable because the laboratories are not identified with outlier results, for example, we calculate what's called a target coefficient of variation, which takes into account the standard deviation. We have that as a fixed amount. Or a fixed value, if you like, as a percentage. So we just set that as a target and calculate then our Z-score. It won't affect the assigned value. The assigned value is still the average, but we're more concerned about the spread of results. And if they're too wide, we tighten it, and we just keep that as being consistent from round to round, that's what's the expected value. And once the program's being conducted for a few rounds, you tend to be able to calculate what that expected standard deviation is going to be. So it's used when there's a variation from what was expected, and you can use the reason behind it is look at past data and calculate what's called a target coefficient of variation, which is one of the parameters into the calculation of the Z-score. And sometimes, not as often, but sometimes the reverse can happen. There's too tight an agreement between laboratories, and one lab is quite acceptable, but by Z-score it's an outlier, but it's not a valid outlier. So then, of course, then you'd have to widen your acceptance. If we think of, most people have seen a normal distribution of results. So in that case, it was too narrow. And when we have a wide distribution of results, laboratories are not being identified with outliers because it's too wide. So we're essentially trimming the data back to be an acceptable level. And that, again, setting a target is an acceptable approach with PT.
Let's stick to this standard deviation issue. I think it is very important in evaluation of the participants' performance in proficiency testing, since it is the criteria for performance evaluation, as it has been called in several documents. And what you mentioned about the target value, to set a target value for standard deviation. What factors should we consider in order to specify this target value? Should we stick to a certain test method? Because in a PT round, there might be several test methods, and sticking to one test method, the standard deviation might be risky. Stick to historical data, or have some mathematical model. I know some famous PT providers always use Horvitz model in order to calculate their standard deviation. What factors should we consider to reach this the most fit for purpose target value for a standard deviation?
You mentioned, Hemadreza, that if you've got a program with many different methods, there might be different standard deviations that are acceptable. That creates a problem. If in the program they're all using the same methodology, then that becomes quite simple because we can refer back to the method and any other data that's in there about precision and accuracy. I still believe if your program, if we talk about historical data, that program may have the same laboratories participating as a group round after round after round. And in effect, what you're building up with that data, with the results that they're reporting, is real estimates on that test. And in a way, it's testing the method. And sometimes there's an expectation with a method that there might be tight agreement, but in reality, that's not the case. And that's why sometimes the proficiency testing data can be used by the method writing bodies to adjust their specifications in their method based on the proficiency testing. And there sometimes with the method, the expectation of agreement is too high and it's not realistic. So the approach or the factors to be considered is, yes, one is the range of methods, and then I haven't got the answer. That is a very difficult thing to work out. If there's a range of different or a variety of different methods being reported in a program. The other factor is then making use of the historical data if you've conducted previous rounds. Apart from that, it's really then the input of the appointed technical advisor to get their professional opinion of where that should be. And I know that doesn't sound like I'm answering the question because we need to relate it to a specific technical area and then have a look at the data, review the methodology, have technical input, and then come up with an agreed variation that would be acceptable. Because at the end of this process, what we are trying to do is give the laboratories an estimate or an evaluation of how did they perform? Are they satisfactory or not? We're not doing the programs to come up with producing a reference value, for example. That's not the purpose. But we have to have, at the end of the program, whatever standard deviation is set, and that I would say is then the estimate for the Z-score, that we have confidence in that approach and we have given the lab a fair evaluation. Okay.
You mean that in order to specify this fit for purpose value for a standard deviation, it is not only a statistical matter, it is also a technical matter, and different inputs from different parties should be considered, and it's a case-by-case matter to have this value and specify how big, how large should it be. Am I right?
Yes, and proficiency, that's correct. Proficiency testing is a combination of statistical analysis and technical input into the evaluation. It can't be one or the other. It needs to be a combination of both approaches for confidence in the process. That's right.
My last question is that I myself believe that I myself as a PT provider believe that even a PT with a low number of participants is still a very powerful tool for laboratory to have a realistic evaluation of their performance. And the labs should not be very sensitive about the number of participants in a PT round, and they should rely on a PT provider, especially accredited PT providers. And they also need to be encouraged by interested parties, such as accreditation bodies, to participate in any PTs which is available. Sometimes in Iran we have this, that the interlaboratory comparisons organized by the labs themselves are considered equal to PTs in accreditation assessments. Do you agree with me in this, or you have some comments about that?
I think a proficiency testing organised by the labs themselves, I haven't got confidence in that, because that's not their specialty. An accredited PT provider is their specialty, and we're working to the ISO standard to ensure the quality. A laboratory organising themselves, I haven't got as much confidence in that process and the outcome. However, doing that is better than not doing anything at all. If it's building up some information for the laboratory on how they're performed, that is valid and should be encouraged. The accreditation bodies, however, should have a preference that they would use an accredited proficiency testing provider. My other comment is sometimes when the laboratories themselves run the program, it might be laboratories within that one organisation. Okay, so they all using the same quality system, and the final report from that proficiency test is that, for example, that all the laboratories agree with each other and they're happy. But they might be all agreeing, but it might be the wrong answer. Now, the benefit of going to external accredited PT providers, we have many different laboratories from different organisations to build up our consensus value. And that we have then a greater confidence in that as being the true value to be compared to. And I think that is the benefit of going to an accredited program. The number of laboratories, I do not have a concern, so long as we've got a confidence in what we say is our reference value, and the standard that we're accredited to allows different statistical approaches to be used when there's low numbers of laboratories and still have a valid performance evaluation, because PT, keep it simple, is an interlaboratory comparison with an aim to determine laboratories' testing performance. So if we can do that by comparison, and we only have 2 laboratories, and we have confidence in the reference, we still have a valid proficiency testing assessment.
Okay, I am finished with my question. Is there anything that you would like to add to our discussion, Philip?
Oh no, just for the people participating from the laboratories, that proficiency testing is there to assist the accreditation bodies come up with a decision on their competence. It's there to supplement the accreditation process, and it gives very good, real objective data on testing performance. I can tell you I do the work well, but PT, I want to now show you, and showing you is my PT report, and I'll show you how I've performed. And I think that's why what proficiency testing providers do is very important for the whole accreditation process, looking at laboratory competence. Thank you.
Thank you very much for this final comment, and thank you very much for your time. And it has been a very nice discussion for me, lots of learning points for me, and I really appreciate your presence here. Thank you very much.
That's my pleasure. Thank you, Hamid Reza.
Thank you. Have a nice time.
Thank you.
Bye-bye.
Bye-bye.